5. So I'm going to start. So we're in section 1.5 now, and here what we're dealing with are inequalities. Now, I did go over last time what an inequality was. I also defined inequalities like strict inequality and this kind of inequality, which is, I guess, not strict, if that makes any sense. And again, I just said what they meant. Basically, for one number to be bigger than another, so like if you have A and B, let's say, right? We say that A is less than B if A is to the left of B on the number line. In other words, the further to the left a number is on the number line, the smaller it is. So for instance here, -1, right? That's less than 0. 0 is less than 1, and so on and so forth. And less than or equal, we allow the possibility of being equal. So here we have strict inequality, which means, again, part of it is that A cannot equal B. But here we do allow it. And B greater than or equal to A means A is less than or equal to B. I did go through this last time, so I wrote down some examples here, but this slide is where I left off. Okay. We also have intervals. Now, with intervals, we're going to need those because we will be considering inequalities. And as I said last time, it's not like with equations where the number of solutions you get is just 1 or 2. With inequalities, your solutions sets will be intervals, and so there'll actually be infinitely many solutions. But here's our first interval from A to B, namely that, by definition, the open interval from A to B. Of course, we're assuming that A is less than B, right? By definition, it's all the numbers between A and B, but you're not including the endpoints. Okay? We're not including the endpoints A and B. And that's what the parentheses are there to tell us that. Okay? The parentheses tell us that we're not including A and B. And now, if we were to graph it, this is what we would do. We would have open circles over A and B. Then we draw a straight line connecting them. So, for example, this here is all numbers greater than 1 and less than 2, but we're not including 1 and 2. Those are not in there. Okay, so again, it's all numbers between A and B. You're not including the endpoints. Again, that's what these parentheses tell you. If you want to include the endpoints, then you have the notion of closed intervals, but these are open. Again, I emailed the notes, so it should be in your inbox now. Okay, follow along. I will post the notes as soon as I can. With closed intervals, though, that's where we include the endpoints. That's where we have these square brackets. Well, I don't know if I should say square, but they're straight brackets. Maybe that's a little bit better. That's just mean, again, we're including those endpoints. So this is all numbers between A and B, but we're including A and we're including B. Also, if you were to graph it, it would just be like the other graph, right, that we just saw, except the circles now would be filled in. Okay. And as with and here, A has to be less than or equal to B. I mean, if A is equal to B here, the only number in here is just the endpoint itself. But if A is less than B, you have infinitely many points. So here, for instance, 1, 2, right? We have all numbers between 1 and 2. We're including, though, 1, and we're including 2. What you can also do is you can go halfway between, so to say, between closed intervals. For some reason, what if you only wanted to include one of the endpoints? With open intervals, we're not including either one. With closed intervals, we're including both. It's possible, however, you may not want want to include either one. That's where these intervals come into play. So with these intervals, as you can see, we're including one point and excluding the other. Now you might be thinking, how do we know which one we're including? Well, the one with the parentheses here, that's the one you include. Here, this is, excuse me, that's the one you don't include. That's the one you exclude, sorry. Here, this is the one we include, as you can see. Same idea here, except we're including A and excluding B. And if you were to graph it, the endpoint you fill in, the closed circle above it. The one with that you don't want to include, you leave that circle, well, you don't fill in that circle. So this would be the interval, including A, but not including B. So I put these examples as well. Here, we're including 1, we're not including 2. Here, we're not including 1, we're including 2. Either way, you're going to include all numbers between them. That's going to happen no matter what. Okay. So we have that. Okay. Now, here, A and B are all real numbers, right? I mean, all the cases, really, A was less than B. I mean, if you had A equal to B, the only interval that would have something in it is when you include both endpoints. But let's consider this now. What if we wanted to include all numbers bigger than 1? You know, how can we write that as an interval? Well, I mean, if we tried 1 to 4, well, of course, this is not going to work, right? We want everything bigger than 1. What about 5? What about 6? What about a billion? That's not in here. So this is not going to work. Okay, what about 1 to 10? That's also not going to work, right? I mean, for one thing, 10 alone is not in there. And anything greater than 10 is not in here. So what am I getting at? Well, if you want to include every number greater than 1, well, not including 1, but you want everything bigger than 1, this will not work for any number B. This will not work for any number B. And why is that? Because, again, there's always a number bigger than B. I mean, just take B plus 1. B could be any number. You add 1, and B plus 1 is not in here. Now, I'm not sure which mathematician first came up with this notation. I want to say it was George Cantor, but I could be wrong about that. But there's special notation that we can use to help us here. And that's what this figure 8-like symbol is. This is notation for infinity. Excuse me, this is notation, and it's read as infinity. Some books will, instead of writing infinity, instead of writing this, they'll write this. And they'll say plus infinity. And this is just notation. Both of them denote they indicate that you keep on going to the right along the number line. In other words, both of those indicate that you keep on getting bigger and bigger forever. Now, I'm not sure if that made sense what I just said. So you could think of it this way also. You could think of this infinity as the end of the number line to the right. Even though I'm not crazy about that, because infinity is not a number. And there is no end to the number line on the right side, in the positive direction. But you're using this notation to indicate that you keep on going to the right. So if you wanted to have all numbers greater than 1, you're going to have to use this notation. On the other side, though, we have this read as negative infinity or minus infinity. Again, it's not a number. It just indicates that you keep on going to the left. That is, you keep on getting smaller forever and ever. Or if you want, you can think of it as the end of the line the end of the number line, that is, in the negative direction. Again, that's not really precise because there is no end. Remember, they're not numbers. I've seen students in the past, maybe I did it when I was younger too, treat these as numbers. Don't do that. They're not numbers, okay? I know it's tempting to treat them as numbers. They're not. They're just special notation. Oh, wrong button. But this is what I was saying though. So for instance, here I put A, but you can think of A as 1 in this case. If you want to include everything greater than a number, you would have to use this notation. And again, this just means you keep on getting bigger and bigger forever and ever. You're including everything to the right of A. And we put an open above A, right? Mostly because we're not including A. But we don't put a square bracket next to infinity. That doesn't make sense to do that. It's not a number. And if we instead wanted to include everything smaller than A, so if instead we wanted to include every number smaller than 1, we would have to use this symbol, minus infinity. Again, that just tells us you keep on going to the left, you keep on getting smaller forever and ever. And here we actually sketch the graphs of these intervals. The arrow indicates you keep on going forever and ever. And again, we can include A, but we don't include minus infinity. Don't put a square bracket around it. The only difference here on the bottom is if we want to include A. Then, of course, you could put a square bracket around A. But again, you don't put it around infinity or minus infinity. I know I keep saying that, but again, it's very important. What's nice also, though, is you can actually get all real numbers as an interval. We have a visualization of it, the number line. As an interval, we can use this. So we have the collection of all real numbers as an interval, minus infinity to infinity. Okay, let me pause it because I have to get to the, what do you call it, the stop recording.